Hi everyone, it's Mr. Rosenberg. This is going to be the first video in our new attempt at a flipped classroom style. And the topic of this video is natural number exponents, where we want to write and simplify expressions involving exponents. We did a little bit of this, kind of just scratched the surface of it before midterms, but we didn't get that deep into it, so I want to get a little deeper into expressions involving exponents. So first, let's talk about the proper notation when we use exponents. Right, so for example, if we took the expression 5 to the power of 4, all right, 5 to the 4th power, 5 to the power of 4, that number 4, that's what we call our exponent, right? And that number 5, that's what we call our base. Now, in exponential form, that's what we call writing it as 5 to the 4th power. This is an exponential form. And the other form, more, I guess, expanded form, would be 5 times 5 times 5 times 5. But, right, we can rewrite 5 times 5 times 5 times 5 in exponential form as 5 to the power of 4. And in this, the exponent tells us how many times we're going to, it tells us how many times to use the base as a factor, right? So in this case, that exponent of 4, that means we're going to use 5 as a factor 4 times. So that's why we multiply 5 by itself 4 times. And general notation of this exponential form, we say is b to the power of n, right? B to the power of n, and that's equal to b times b times b times b, and the b's keep going on as far as whatever we plug in for that letter n, for that variable. All right, so that expression b to the power of n, that tells us that b is used as a factor n amount of times. So, right, so in 5 to the 4th, 5 is our b and 4 is our n, right? That n value of 4, that tells us to use 5 as a factor 4 times. Now let's talk about writing in exponential form. So here we have this example, 6 times 6 times 6 times 6. So we're going to be using a base of 6. And here our exponent, 6 is being used as a factor 1, 2, 3, 4 times. So our exponent is 4. And so we can just rewrite 6 times 6 times 6 times 6 as 6 to the power of 4. We can do the same thing when we're working with variables. Here, our base is going to be the variable a. You can see a, let's go back here. And here, this a is being used as a factor 1, 2, 3, 4, 5, 6 times. So our exponent is going to be 6. So we can rewrite this as a to the 6th power. For this last one now, we're dealing with multiple bases and we have whole numbers in there. Right? So what I like to do first, when we get to an expression like this, just identify each base you're going to use. Right? So we have a base of p, we have a base of q, and we have our whole numbers 3 and -2. And then we're just going to look at them one at a time. So if we start with our whole numbers, first we have 3 and -2. So that's 3 times -2, which is equal to -6. Then we have 1, 2, 3 p's that are being multiplied. So that's p times p times p, which is p to the 3rd. And then last we have 2 q's being multiplied together. Q times q, that's q squared. After we do that for all of our bases, all of our terms, we can just combine these 3 with multiplication. So when we do that, we end up with -6 p cubed q squared. All right, now we're going to talk about expressions that have parentheses and exponents in them. So for example, in this case, we have 2y inside a set of parentheses and 3 on the outside of our parentheses. In a case like this, when you have a term or an expression inside of parentheses raised to a power, everything inside those set of parentheses is your base. All right, so here our base is going to be 2y. Let me write that a little better. And our exponent is 3. So now we have to raise 2y to the third power. So in expanded form, that would just be 2y times 2y times 2y. Now let's take a look at this example. Now we don't have any parentheses. We just have 2y to the third power, or 2y cubed. So here, that exponent only is applied to our y. All right, there's no set of parentheses, so whatever that exponent is attached to, that's what it goes with. So here, our base is just the variable y. And the exponent of our base here is 3. So when we would write this in expanded form, first we have our coefficient, right? Our coefficient here is 2, so we want to include that. Next, we have y to the third power, so that's just y times y times y. And that's it. We just expanded from exponential form to expanded form.